see still quite a few people joining, but I would like to welcome everyone to GlobusWorld 2021. My name is Vas Vasiliadis, and I will be hosting the session for us here today. Thank you all for subjecting yourselves to another lengthy Zoom session. I'm sure you're all tired by now, but we really appreciate you joining us. We've got some great speakers lined up for you. But before we jump into the program, I would like to call out the hashtags that we're using today. If you wish to share any of the messages we're communicating, that would be wonderful. I would also like to thank our sponsors. First off, Quantum is a platinum sponsor and a first-time sponsor of GlobusWorld, so thank you very much for their support. Likewise, Fujifilm joins us for the first time. Intel is a returned gold sponsor. Internet2, likewise, has been a partner with Globus for many, many years. iRods is new to the family as well, and we welcome them. We have some product announcements related to iRods as well. And likewise with Microsoft as a first-time sponsor, thank you to all. And Wasabi returns again as a gold sponsor. Thank you to Wasabi. We also have two Patron sponsors who are also longtime Globus supporters, Cloudy Cluster and SpectraLogic. So thank you, everyone. Our talk today is titled Foundations for the Future of Science. And it's my great pleasure to introduce Ian Foster, who's the co-founder of Globus, going back well over 2 decades now, not to date him too much. So I'll hand it off to Ian to lead us into the keynote. Yes. Thank you.
Okay, wonderful. So it's great to see so many, well, old friends, new friends, despite the fact that we're not meeting in person. It's now, more than a year since we first locked down to varying degrees. So this has given us an occasion to, well, do some things the way we used to do them, and in some ways to change the way that we work. So one of the things I've been doing is reading more than I used to, including Dickens. And perhaps this motto here is timely for us as computer scientists and data scientists, data managers, data wranglers. Clearly, for many of us, it's been a very difficult year. We've had tragedies, inconveniences, many difficulties, but it's also been, for some of us at least, the fortunate ones, sort of an exciting time, in that we've seen people come together, scientists and engineers, to work on projects of a type and a scope that we perhaps had not previously been able to undertake. And I think that's a very exciting aspect of the last year, and something that I hope we will learn from as we plan our work for the next year, 2 years, decade, and beyond. How can the scientific community come together and work collectively to tackle challenging problems? So one of the things that I've been fortunate to be involved in, along with many others, was various responses to the pandemic. For example, projects involved in identifying therapeutic drugs for use against COVID. So I won't go through scientific detail, but you probably recognize this is a picture of a COVID protein, and you may see the little drugs that my colleague Arvind Ramanathan has visualized here, attempting to dock in one of the pockets. This has produced some wonderful scientific results, but it's also engaged people across many different institutes, disciplines, and communities as we have attempted to make sense of this. So for example, as we'll hear a bit more later, scientists at the Advanced Photon Source were conducting experiments around the clock to determine the structure of some aspects of certain COVID proteins. A key issue, it turned out, was finding out their structure at room temperature rather than at cryogenic temperatures, and this provided new insights. Another group of people was engaged in building pipelines that would compute characteristics of literally billions of small molecules, assembling a data set of tens of terabytes, I think more than 100 terabytes in total of computed properties. This is something that harnessed resources across the US and Europe, supercomputing resources, data resources, networks, and so forth. Was exciting for us both because of the science, but also because we were using Globus mechanisms throughout many of these projects. But I think they all suggest, ways in which people are probably going to be working much more in the future by harnessing resources on global scales, working across boundaries that perhaps they would not have attempted to traverse before, and building new infrastructure to enable those sorts of collaborations. And this, there's already really exciting results coming out of this, and I won't go again into the details, but just to mention that fun things are happening. So that COVID response is one example of a exciting team response to a national problem. Another activity that I've had a minor involvement in, led by Pete Beckman and really a cast of world-class scientists across the US and internationally, is looking beyond how to respond to the current pandemic to the challenge of building a national pandemic observatory, perhaps ultimately an international pandemic observatory that can track information from natural systems, agriculture, cities, in buildings, sampling sewers. How's that? That's a fun job to have. Perhaps not, but very important. It's something that people are doing in Chicago at the moment and in many other cities, with the goal of being able to allow people to observe data from thousands, perhaps ultimately millions of different data sources, collect, integrate, learn from, introspect the resulting data products, observe interesting patterns in them, perhaps a sudden increased death of some species in a natural system, or perhaps the emergence of a new variant of a microorganism or a virus in sewage water from a city, and then define experiments which are perhaps conducted entirely on a data commons containing all data collected to date, or perhaps involves pushing new experimental protocols out to edge devices. So this is a whole new way of doing science, which I think very much has been motivated by the realization that the world is not really ready for the next one of these effects, these events, and needs to be prepared. So that's a very exciting set of activities. So looking through data paths like this shown here, we see data volumes and data variety that humans alone, even in large teams, cannot cope with. So AI methods are increasingly being deployed in these systems. So I think that's another aspect of science today that makes things very exciting. So the OE, one of my employers and sponsors, observed this year, I guess, last year, that the next frontier for science as a whole, not just pandemic response, is going to be applying data-driven methods at extreme scales. So that doesn't mean giving up on theory, but using data-driven methods perhaps to identify areas where traditional theory breaks down or can be enhanced or can be applied in new ways. So this is another aspect of how science and the practice of data, which is Globus is concerned, are changing and are going to be changing in the coming years. We're very excited about AI for science inside Globus and also in my group at Argonne in Chicago. Partly because of the new capabilities we see coming out of the so-called AI or machine learning communities, but also because of the new demands that we see arising from pandemic response, new scientific instruments, national observatories facing down, national astronomical observatories facing up, environmental observatories, and so on and so forth. It's clear that we can't solve many of the interesting problems that are raised by these systems using existing techniques which tend to emphasize individual researchers looking very hard at data or building their own individual simulations. We need more team-based approaches, AI-based methods, and increasingly sophisticated and complex responses. One of our perspectives is that, we're going to see a new class of, if you like, programming systems or apparatus, the systems that are designed, for example, to integrate all available knowledge and data about how to design things like materials, polymers, organisms, pandemic responses, and automate the process with lots of human input, of course, of how to address these design problems. We're going to see increasingly sophisticated systems for driving laboratory experiments, self-driving laboratories, autonomous experiments, again, driven by the assembly of large amounts of knowledge from many sources. And underpinning all this may well be new systems for making sense of the vast amounts of data that we have assembled to us, the 100 million scientific articles that are available, the data that's being produced at terabytes per second in aggregate across the scientific community. And at the top here, we say AI science applications, one per planet. Well, maybe it'll be more than one, but how many different systems will we have for making sense of the scientific literature and associated data? Increasingly, I think we're going to see team-based collaborative systems that are designed to support many applications, because the there's power in numbers in many different regards. So perhaps some of the building blocks that we're going to see communities building, people at Argonne are very engaged in building these things, would involve things like the following: methods for design, as I've shown, for controlling things, for enhancing and accelerating simulations by, for example, the use of AI models to choose what to simulate next or to approximate expensive computations, and so on and so forth. I won't go through them all. Autonomous labs, an exciting direction. On the bottom right, I show a commercial autonomous lab that we've been making use of. But increasingly, I think people are going to be building their own. Perhaps the national labs will be a place in which you will send your requests in the future to design a new polymer for a particular purpose, with experiments, simulations, and the collective knowledge of the scientific community all brought to bear on that a single design problem. Very exciting directions. So, well, here's one final example. I think this is my second to last slide. Science, as far as I can tell, is increasingly going to be driven by systems that combine robots of different sorts for autonomous science, simulations for making sense of based on theory of what may be happening, digital twins used to guide the choice of the next simulation or experiment to perform, and massive databases of past results, the scientific literature and so forth, providing the priors that will help to guide our work. And all of those things are going to require new approaches to scientific infrastructure. Here's a picture I drew a little while ago that attempts to picture what the new scientific infrastructure might look like. Historically, we've tended to think of infrastructure as experiments, in one place, supercomputers in another, perhaps a data repository somewhere else. These things all need to be connected together in a far more fluid and flexible manner than they are at the present, with probably new sorts of agile infrastructure supported by new sorts of system software that can allow the use of this agile infrastructure. And in many cases, this ensemble driving the use of new AI methods of various sorts, linking out to very rich data sources. So these are exciting directions. I think they're coming anyway, but our experience over the last year attempting to assemble national and global scale teams to tackle new problems resulting from the pandemic and likely to result from future events of that type, I think make them yet more urgent. And it turns out that underpinning many of these systems that I'm talking about and many of the problems that we want to tackle with them is data, the ability to acquire data, move data, transform data, find data, and so forth. And so that's sort of a fun thing for us involved in Globus, and hopefully also for those of you who are joining us today. Turns out what we're doing is central to at least some aspects of the future. So on that note, I will I think hand things over to who's next up. Rachana. Thank you.
Yes.
So I've stopped sharing and you are sharing. Good.
You're seeing my screen?
Yes.
Okay, excellent. Okay, well, thank you everyone for joining us today. For this next part of the keynote, I'm going to start by describing some of the impact that our work here at Globus has had. This is a pretty critical piece for us. It keeps us, stories like this, keeps us motivating to keep doing what we're doing and innovate to support some of the future vision that Ian described today. So the first one I'll start with is something that's been top of mind for all of us here, the COVID work. Ian talked about some of the work being done at the DOE complex and specifically Argonne National Lab. And this is specific work that is done at APS for understanding the protein structure as Ian described. And Globus was used for data management from the experiment stage all the way to data dissemination, right? So the whole, several services of the platform was used. The thing I wanted to highlight about this user story is the quote on this slide from the Beamline scientist about how the data management services helped dramatically reduce the time to results on this, right? This quote speaks directly to our mission in terms of increasing efficiency and effectiveness of researchers. So it's very gratifying for us to see our services being used in this way. The next one I'm going to talk about here is about facilities. Cryo-EM facilities, there are quite a few here in the US, and we are highlighting a couple that are using Globus for data management at the facility. The Case Western Reserve Cryo-EM Core, and the other one is the Pacific Northwest Cryo-EM Processing Center. In both these places, the reliable and scalable aspect of the product, but most importantly, the administrative interfaces that we have that allows them to manage all of the data pipelines for the users makes it very compelling for deploying this, right? And we have seen quite a bit of volume of data and number of users on this, particularly the one with Oregon Health Sciences University. They have a data pipeline where pretty much every day, tens of terabytes of data moves from the Oregon Health Sciences University instrument to PNNL, Pacific Northwest Lab, for computation and analysis. So some of these automation and management of those pieces have allowed them to scale and provide these distributed pipelines for their users. This one talking about a different kind of facility. This is a bioinformatics core at the University of North Carolina. And they have a need to support a global collaboration where they have users all across the world with whom they need to share data for various cancer projects. The most interesting thing about this use case is the wide variety in different dimensions, whether it's different types of data that they're sharing, different scales of data. You have small data to multiple terabytes that are being shared, different types of storage system that they need to bridge across, and of course, different users from multiple locations, right? So having Globus as the ubiquitous interface, a single plane of glass behind which all of this is supported, plays a role for them and allows them to scale up to the sort of collaboration they are supporting. This one is a completely different domain and from University of Winnipeg up north. This is a group of researchers who are working on machine learning models to identify features that require specific mitigation, such as targeted pest control and such, to increase crop yields, right? Completely different domain, digital agriculture domain. And the use case here is they are gathering data from distributed resources, about 40K images per day, and they need to be able to move this data across multiple tiers, from the first machine that is acquired, which could be a simple Windows PC, all the way through campus storage onto the Canadian National HPC Center, which is Compute Canada. So there's different tiers, different scales, and different platforms, and they're using the Globus transfer interface to be able to orchestrate this. So platform as a service and the CLI plays a role for them to be able to provide this. Cosmology is my next use case here. So Globus is being used for almost 20 years now in high energy physics in different ways. At least the data transfer pieces have been used in many different ways. But this use case is very interesting, where it is not just about moving the data, but it's actually providing means for easy data access. So Dark Energy Science Collaboration is preparing for the arrival of Rubin Observatory. And they are creating simulation data that they then have to make available to their collaborators, so they can then use that data for testing and building out science pipelines. So the question here is not, can you move this data? It is, how can you make it easy for the vast number of collaborators to come and find this data and access it, right? So they adopted the data portal that Globus makes available as an open source, customized it a little bit for their needs, and made it available for their collaboration. So now their users are able to come in, log in, find data sets of interest, and then download it or transfer it and use it for their needs. Tying that to the next example that I have here, which is moving from providing data just for a collaboration to providing data at a national scale. This is a very exciting project where Canada is invested in a national data repository. It's called the Federated Research Data Repository. This project went out in production a little while ago. And the goal really is to make this available as a place for any Canadian researcher to deposit both their, essentially their research data. So they put in metadata, but they also put in data so the other researchers can access it. So it's a very classic publication platform here. There's the ingestion, somebody curating it, and then on the other side of the equation, being able to discover this and cite the data and such, right? Very early on, Federated has been a collaborator with us, and they've built a lot of this using Globus services to ensure they can scale to any data sizes. So they use the Globus authentication platform, transfer, and also Globus Search, which I'll talk about later today. So it's a really wonderful use of something that is coming in at a national scale and provided to the researchers to make their data available at writ large. The next two examples I have are more platform or tool examples. So this one is a project out of University of Southern California. The toolkit or the service is called Deriva, and it stands for Discovery Environment for Relational Information and Versioned Assets. So essentially what it is a asset management platform, and it focuses on structured data and making it easier for someone to create and manage big data sets and relational structured data sets and use it in their analysis. So they have their own access pattern, as you can see from the slide here. But what they needed was a security platform. So they are leveraging the Globus Identity and Access Management Services, Auth and groups, for authentication and for role authorization based on roles. A key thing worth highlighting here, most people think of GlobusAuth as a way to secure web-based applications, but GlobusAuth also has support for thick clients or desktop clients. And that's a key piece for this group, where they not only distribute, they not only have UIs, but they also distribute desktop applications. And they're able to use the same security infrastructure to provide that. This is really widely used in several NIH-funded projects. You can see all those logos there. So it's very exciting for us to see a significant adoption of the security platform in this case. And the second platform use case that I want to touch on is from the materials world. This is an NSF CSSI project that is focused on trying to solve the problem of identifying or discovering high quality data sets in that space, but more importantly, being able to understand the data, the format, and how it could be used. So ultimately somebody could use it in their analysis, right? So with that in mind, they're focusing on providing a repository that allows people to not only deposit their data, but also provide copious metadata and tagging and such. And for this, they've built this off the Globus Search service to allow users to come in and not only browse and discover data, but also be able to query for data sets, right? The distinction being with the query, you can get the exact set of data that meets that requirement, which you can programmatically then add into your analysis or use in your downstream processing. So this project is using other platform services, Auth and Search and Transfer, to provide a comprehensive way for materials data to be made available and more usable. And they have more than 1 million material band gaps from multiple databases that's available as a part of this. And then the last one, and a completely different angle to the sort of user stories I've talked about, is the adoption we have seen at national scale of Globus at various places, right? So I'll start with Compute Canada. They are probably the longest we have had association with them, very early adopters of Globus. And they have been providing Globus on their national infrastructure for users for many, many years now. NESI, the New Zealand eScience infrastructure, is the other one. Again, very early adopters, and they, in partnership with their National Research and Education Network, their NREN called REANS, are now offering this as an option for all the researchers in New Zealand. More recently, we've had really good engagement with South Africa. The NICIS, which is their national cyber infrastructure, is working on this in collaboration with their NREN called SANREN. And here they're really gearing up for effectively participating and leading a lot of the global initiatives, global research initiatives there. And lastly, Australia. So again, we have had use of Globus in Australia for a number of years, but it's very gratifying to see sort of more programmatic adoption and support there. So CSIRO, which is sort of like National Science Foundation here, has been a subscriber and has provided Globus to all the national facilities. And recently we worked with RNet, which is their NREN provider, to provide Globus to all their researchers, right? So it's wonderful for us to see all these different science use cases, but also coming at it from an infrastructure provider, seeing this adoption and making Globus available at this scale. So I want to very quickly touch on, when I talk about all these use cases, what are the things available today? There are really 3 big pillars to our platform. First is secure and managed transfer. Second one is data sharing, where you can share data with your collaborators without having to replicate it to different storage system. And then I think the third key part of this is providing all of this as a platform. So it can be integrated, whether it's Science Gateways, Jupyter Notebooks, be able to use all of this functionality with your applications. And again, we have had a wide variety of storage systems, different types of storage systems, and integrated into the research identity space. So you can use federated identities into all of this ecosystem, right? So given this, switching to what's coming next, what have we done over the last few years and what are we announcing today? So the first product I want to touch on is Globus Search. You heard me refer to it in many of the use cases, and we are now making this available in production to all users. This really is bringing scalable, secure search for research data. And that means a few things, right? One is very obvious, integrating it with the research ecosystem, the identity management and such. But also there is fine-grained visibility controls on the metadata so that you can decide what is available to whom. Making this schema agnostic, which just means that Globus doesn't impose a schema, so you can bring your own domain-specific schema to your search indices and have metadata that's very specific to your scientific domain. And then providing a method to not only do free text search, but also the whole faceted search, right? Think shopping cart, Amazon kind of thing. So you can come in and do a full discovery, but for scientific data. So those are sort of the key drivers here. And of course, the query piece that I talked about, right? Being able to come in and ask for a specific set of requirements, data that meets the specific set of requirements, and being able to get that out for programmatic integration. So this service has been around for a while, largely used with friends and family projects. Now we're opening it up to everyone. And you can see here an example of a group at Argonne who does cosmology, indexing all of their simulation. And you can see the facets here are all specific to their domain, right? So somebody can come in and narrow down. And of course, additional metadata gives people more information, but really interesting is adding links to the data itself. So once you search and find things, you can actually access the data and download or transfer it. So search is now available in production. There's a lot of documentation on our usual doc site. You can go try it out. It's open to everybody, and production use will be covered under the standard subscription tier. I also want to just call out a walkthrough, the last link here that actually gives you an end-to-end with sample files and everything, where you can see what it looks like to index a little bit of your file metadata and do a search and query, right? So that's one. The second one that we have spent a lot of time on and are very excited to have this now available to everybody is our Globus automation services. So this platform allows managed and reliable task orchestration across heterogeneous resources. And the tasks essentially ways to construct pipelines, or we call these flows in the system. The task itself can be literally anything from an asynchronous task like running a job to something that is near instantaneous, to something where there's a user in the middle, somebody having to be notified, fill a web form. So you can now construct these flows or pipelines and have them be managed and run. And be across heterogeneous resources, so distributed, where each of the steps in this pipeline could be running at different locations and managing the security through those. And ensuring that these flows can be created with just declarative language, so you don't need to write new code for composing these things. And the point there about customizable actions is making sure it's a platform, right? Where the actions that you have in the flow can be things that Globus provides, but also that other infrastructure providers are able to plug in any of their services as things that can be used in the search. And lastly, we need to think about scale on this. Somebody could manually run a flow or a pipeline, but also you can do triggers. Run this every time data gets written to this disk, or every time a data set has been captured, or every 2 hours, right? Triggers that actually run this pipeline. So there are 3 aspects to this. The first one is creation and deploying a flow. And you see some examples here. They could be simple linear ones. You could have choice that determines which path this takes. And you would write this using JSON or YAML. And you can set policy in terms of who can run these and who can access these. And then a user can come and find a flow and then run it. It's essentially execution and provide input parameters, right, for running that particular instance of the flow. Check the status and such. And again, this is where the snapshot you see here is our new web UI, which is just released yesterday in beta, that allows you to start these things, but you could also have triggers that allows you to run these flows. And the third aspect of this is the action itself. So when you run these flows, each step does something, and those are called action providers. And they have to be a service. And you can see it has these few invocations that you want to allow there. Globus offers a bunch of these. Most of the things that we do, we offer them as something you can add in a step to your flow. And there are other people who have added their own custom actions as well. So for example, the extract one here sees the format of the file and extracts metadata from it. And the next step would be ingest, which pushes it to a search index, right? So those are the 3 pillars here. Let's just talk about how it comes together, right? So we anticipate, you would have a bioinformatics core or a beamline scientist at an instrument facility or somebody at RCC potentially defining these flows and making them available to their researchers, right? And they would be using various action providers. These action providers actually are services that need to be run and hosted. So we expect to be more infrastructure providers. If you have an analysis, you could wrap it as an action provider, so it can be a step, right? And then lastly, from a user perspective, they should just be able to come in and invoke this and use it without ever having to do any of the coding or writing the JSON. They just provide input parameters and run it. So that's kind of how the whole system come together. I'll do a couple of examples here. The first one I'm going to talk about is the NIH project called Common Fund Data Ecosystem. And the project is looking to standardize data discovery and ease of access for data that is available through this set of coordinating centers, data coordinating centers, which collect and manage data from various awards in the NIH. Now, the idea here is to allow the DCCs to deposit metadata, and then for CFD to provide a single interface, a portal where a user can come in and discover data sets that are available, right? The step where they're depositing the data, they've done this using Globus Flow, and it allows them to offer this to their users, get a managed solution for it, and more importantly, reproducibility, right? So there is a well-defined flow that does the deposit. So they're using Oauth groups and all that for security, but also flows for automation. And then a second one, you're seeing lots of adoption in the instrument space. So you're seeing lots of instrument examples. This is the tychography group at APS, and they're using this technique for imaging. And this technique, apparently, there's very high data velocity, and the analysis is very iterative and very time consuming. So they implemented a Globus flow that essentially does the pipeline of transfer, analysis, and feedback to essentially dramatically shrink their time to result, right? And allows them to run these pipelines concurrently, scale it up using triggers, and reduce how long it takes for them to get feedback into the experiment itself, so they're able to adjust the experiment. So these services are now available in production for all our subscribers. Anybody can try it, and the services are available for production use under subscription. And here's tons of, if you go to docs.globus.org, there's lots of documentation, and there's a CLI and SDK. Right? Okay, so switching from 2 new platform services that are released, sort of some of the existing pieces and where we are and what has happened in that space, right? So for anybody who's been a user of Globus, Globus Connect Server is how you plug into our data ecosystem. and we did a significant re-architecture of that piece. Just want to take a moment to sort of lay out key motivations for some of that and what that has enabled, right, with GCS5. So one of the first things is web addressable storage. So the same data that you used to do bulk transfers is now accessible through HTTPS, and that opens a world of possibilities in terms of what you can do there. We also moved away from user certificates to more web-friendly technology like OIDC, supporting different types of storage systems. So you can have a single endpoint that supports things like POSIX and S3, high assurance features. So there's a lot of new things that GCS5 brings to our whole platform. So it's now feature parity with V4, and all new installations should use GCS5. We've added a few more features just in the last 6 months based on feedback from the community. You can have custom DNS names, so your data could be hosted on something that is in your university or campus DNS. We've added support for multi-factor authentication for high assurance collections, so you can require that before access happens. We've added more fine-grained sharing policy, so administrators can further control who shares what. And then also containerized deployment, which I think has been a big win, and we have already seen quite a few people try it out and provide us feedback. So this is available under our open source repository. So if you have changes or additions and suggestions, we're happy to take that as well. On GCS5, we've supported lots of new connectors. The big one for this year is the Microsoft OneDrive connector. Brings sort of the same features that we like and love with the Globus transfer, file and forget transfers, all of the data sharing, all of that to OneDrive. This was available in beta for a little bit and now available in production for all subscribers. The second piece here is last year, we built out a community connector program to essentially meet the demand and partner with the community to provide support for different types of storage systems. So through this, we work with anybody in the community who wants to build out a connector for a particular storage system. And the work is done together, testing and validation, and then ongoing support is also shared with the partner. So the first one we released like that was Globus for iRODS. It essentially brings all the transfer features, the egress and ingress of data to our iNOD storage, data sharing, using iRODS within storage within a publication flow. All of that becomes possible with this. And the iRODS team built out the connector, and we worked with them, and this will be a joint thing that we will support with the iRODS team, right? Similarly, we added another connector, which is a POSIX staging connector for any file system that needs to cache data. So you get it from tertiary storage and cache data. So we have the basic framework, and a custom plugin for staging the file is added by partners. So one example here is the University of Michigan. They have built out a connector for the IBM Spectrum Scale, the plugin for the IBM Spectrum Scale. So we continue to keep growing these. The slide gets busier and every year. And if you have additional storage systems or you want to partner with us, please reach out, and we can certainly look at how we can add that to this. Moving away from data for a second, a couple of other updates. Globus Groups, the community has been using that for using our SaaS platform. We now have the API and the platform itself available in production. One of the most asked features has been the ability to add users in addition to being able to invite them, and that's available in V2. And we've also made some simplification to membership policies. So that's, again, documentation is published and it's ready for you guys to integrate with your applications. On transfer and sharing, lots of updates, lots of improvements. I want to highlight 3. The first one is what I sort of think about as conditional error handling, right? So by default, when you submit a transfer to Globus, it succeeds only when the destination looks exactly like source. This is our first option where you can override it and ask for file that had the errors of file not found to be skipped. And once the transfer is done, you can get a list of files that were skipped. We also have an option where you can ask for the task to fail if there's a code error rather than wait and retry, right? And then we added scheduled and replicated transfers. I know a lot of you are doing this by either having your own cron jobs or scripts, but now you have a hosted solution for that. You can come in and ask for transfers to run repeatedly, schedule for them to run at a particular time, and it's supported both for transfer and sync tasks, right? And this has been written as a general timer, which sort of plays into our automation platform, because this timer can be used to start other flows as well. So that's the arc we are pushing on this. For now, this timer largely does transfers and sync tasks. So I just want to take a minute here to pull all these pieces together. We have GCS5 and the automation and search. I want to talk about one project that is sort of using all these different pieces to give you a flavor of how you could build out a complete data management solution. So this is a group at the Advanced Photon Source that does X-ray photon correlation spectroscopy. That's what XPCS stands for. And they're using Globus Search, Oauth, and groups here to make data discovery possible, right? So only select set of users can access it. You see facets and everything here. And then because they are able to connect to the actual data and we have HTTPS enabled, they're able to do things like this where you can preview or show thumbnails, and you can really access that file without requiring a full bulk download, right? Of course, bulk download is still available for cases where people have to move. And then the last piece of this is reanalysis. So the Beamline scientist has written a flow on how you would sort of analyze the data here. And that is an option here. You can see the reprocess button. So now a user can come in, select data sets they're interested in, and trigger a reprocessing, and the flow runs. And you can sort of think about that as a full loop, right? Now you have results that again get ingested into the search index, and now you have data available. So putting all of these pieces together and use with a customized portal interface, they've been able to build something that's pretty complete for their project. So switching now, so that's a lot of what we've done, announcements. So I'm going to talk a little bit on what's coming up ahead for us, and then turn it over to Kyle, who's going to talk about things further down in the pipeline. So on Globus Connect, definitely the big focus for us is migration, supporting everyone moving from our version 4 to version 5. You'll see this migration happen in phases, and you'll start to see migration tools available for this end of Q2, Q3. And by phases, I mean classes of endpoints. If you're using my proxy, if you're an endpoint that uses federated login, and so on. The goal here is to not require any user intervention. So we expect the administrator will be running these tools to be able to read a v4 deployment and configuration and set it up on v5. Then IPv6 support, it's been asked by quite a few customers. That's on our roadmap for this year. There are 2 planned connectors. One is the Azure Blob connector, which kind of rounds off all our at least big public cloud object stores. And then in collaboration with Argonne, we're building out Intel DAOs, which is Intel's distributed asynchronous object store. We're building out a connector for that for their use, and it'll be available for all the Globus users as well. On the other platform services, on the data piece, there is a growing body of use where there is a single application or a set of applications that are proxying for other users or managing tasks for other users. So we're starting to look at how to support use cases that need higher throughput, right, on transfer tasks. And then enhancements to data permissions, so setting ACLs with expiration, setting permissions that have one-time use, and so on. Consent management is the other aspect where we plan to spend a lot of time this year. It's become very central to our services now. All of Globus Connect 5 uses it. All the automation services use consent to allow fine-grained security. So how do we ensure that the user interactions there are clean? There's a engagement with through the CFD project I described for integrating and leveraging the new researcher Oauth service at NIH and figuring out how that can be used as a part of our platform. So that's something that we'll be working on this year. And on the search service, making it available for high assurance tiers, so you can put data that requires higher protection in there, and also leveraging search for our own resources. So when you search for groups and such, using our own search service. On the automation platform, this is the platform services, the CLI, the services are really feature rich, and you see we've used it in a lot of use cases on our current projects. But really the focus is going to be broader adoption and lowering the barrier for adoption. This is our first release of the web app and it's in beta. So you'll see us do lots of rapid iteration, new features in there, and also supporting more excellent power flows. So how do we support some flows that are just available for you that do basic instrument handling or even data processing, right? And as with all services, we are also working towards getting this supported in the high assurance tier. So this automation services can be used with protected data. And then lastly, the clients. If you are looking at some of the documents I pointed to, we now have lots of different clients. The automation services have their own clients, search has its own. So we'll bring it all together under the single Globus client umbrella. On the web app, there's an updated management console that's for sort of usability, accessibility work that's happening, and continue to work towards the accessibility standards. I think last year we'd mentioned this as a big goal, and we've done quite a bit of work there, continue to finish that off. And the last one I want to talk about is very quickly on the sample portals. So for years now, we have had a portal that it's called a modern research portal. And we have open sourced that allows you to essentially stand up a portal that has basic data access, authenticate and use Globus and access data and discovery. And it's amazing how much it has been used. We see lots of deployments of it, still with the same picture that I think Vas chose, one GlobusWorld. And we have seen it to be really useful, and lots of projects have stood that up to make their data available, right? So we're going to invest in resources to make that a first-class supported piece in Globus and make that available as a starting point for projects to pick up and use that for distributing their data. So some customization and distributing their data, with the goal of essentially making something like that XPC as example I showed you reachable and not too hard for various research projects. So that's going to be a focus for us this year. Okay, with that, I'm going to turn it over to Kyle to tell us more about labs and our future project pipeline.
Awesome, thanks, Rashna. Let me share my screen. You can see my full screen share there, Rashna?
Yep, looks good.
Awesome, okay. Well, thanks a lot. So, hey everyone, I'm Kyle Chard. I'm going to talk more about things that are maybe a little bit forward-looking, a bit further away in the pipeline. We're talking maybe years, months, rather than weeks than the time frame that Rashna's mentioning there. And so Ian and I work with a great group of students, postdocs, research software engineers, and others at the University of Chicago and Argonne. And we also have collaborators at various institutions. Some of the work I'm going to talk about today is a collaborative project with the University of Illinois. And these people here are really sort of pushing the envelope in terms of the types of things we can do. And the hope is that a lot of the projects we're working on will actually inform future Globus products and directions. So I'm going to focus on two projects. I'm going to talk first about FunkX, which is a new system we're developing, and then I'm going to talk a little bit about how we're applying Globus platform features to various science problems at Argonne. So I guess one thing we've probably heard a lot over the last decade since we released Globus was how useful it is for managing data, and how useful it would be if we could apply the same concepts to managing compute-like functionality. I think when people talk about this, they're really focusing on a few things. They like the sort of single interface, the cloud-hosted service where they can speak to one sort of API and manage their data across lots of endpoints. And of course, the analogy of being able to do that for compute would be very useful. They like the model, the fire and forget model, where you can just tell Globus to go and transfer something and you don't have to worry about the details. You don't have to worry about failures, etc. The sort of federated security model, where we have this nice authentication, we can speak to different endpoints without needing to SSH and do all the other bits and pieces you would otherwise need to do. And I think the primary reason is really the ease of use of the Globus model. So making things super simple that anyone can sort of pick up and get running very quickly without needing to understand all the complexities of these very large clusters and HPC systems. So over the last couple of years, a group of us, an increasing large group of us, have been building this Funkex prototype system. And I should say that this is very much research software at the moment, but we're really looking here to build out this service as a production part of Globus over the coming years, and we have some funding from NSF to do so. So before I get into what Funkex is, I'd talk a little bit about what the requirements are that we see for sort of managed compute in this space. And the first thing is we need some way for people to be very easily able to, from the comfort of their PC, be able to drive some large compute tasks across the computing ecosystem, be it a supercomputer at Argonne or a cluster in my university or some other national cyber infrastructure that someone might be using. We need to make it very easy to move between these systems. So increasingly, I think we see this need to run compute tasks on some sort of exotic heterogeneous hardware. I want to move my machine learning algorithm to run on some GPUs, or I want to be able to run on a particular type of architecture that happens to only be in California, etc. We need to make it very easy for people to be able to share these functions so that these compute tasks, so that their collaborators don't need to start from scratch and write things from the beginning. So they can take something that already exists and they can go and run it close to their data, for example, on their instrument. We need to make it easy to share allocations. I think we commonly face this problem of groups of people wanting to share an allocation on a particular system. They want to use a community account. They don't want to go through the challenges of setting up individual user accounts for the potentially large group of people that might be using things. But they want to be able to at least audit that and see what's happening and control it in a more dynamic way. And finally, I think we have this requirement increasingly, and we see a lot of this, is that application developers, gateway developers want to be able to build on top of sort of higher level abstractions. One of the things the cloud has done really nicely is make it very easy for developers sort of to pick up a suite of components and cobble them together and build very sophisticated applications really quite quickly. And of course, the Globus platform is doing that for the data side of things. So when we started thinking about how we should offer a managed compute-like service, the biggest question was, I guess, what sort of interface should we provide to that service? And I think there's a lot of options here. And of course, our group over the years has a lot of experience building interfaces to various computational resources. But we thought we'd step back and take a look at, well, what's sort of out there at the moment, what's up and coming, what's really focused on usability. And one of the models we thought was particularly attractive was this new serverless function as a service model that the cloud providers have adopted. And the FAST model is really, I think, super convenient, because the whole idea is to try and abstract the infrastructure. It's to try and abstract the hardware and even the virtual infrastructure, the virtual machines and containers that things are running on the cloud, and make it such that developers really think only in terms of the functions they're using. They think in terms of a programming mindset. So essentially they define a function they want to run in something high level like Python or JavaScript or another language. They code up their function, they register it. Once it's registered, they've got a pointer or a name to that function in the cloud, and then they can run it one time, or they can run it a billion times by parameterizing it, and it very easily scales. So they don't need to think about, well, if I want to run this thing a billion times, I need to provision a million cores over some machine. Essentially, it's just completely elastic. It's very low latency. It dynamically scales depending on the actual workload. And so we thought what would be cool would be if we could take this function as a service model, which currently sort of works in a centralized manner in the cloud, and can we adapt that to work in a federated environment so that we can actually distribute lots of little tasks across lots of potentially connected systems. And so what we've done is we've built out this Funkex service. We're on our probably second or third generation now of the service. And as I said, we received NSF funding approximately a year ago that's going to support us for the next couple of years to really make this a production capability as part of the Globus platform. So what is Funkex? In a few bullets here, it's a cloud-hosted service, so very much everything here, you should think of the analogy to how Globus works, because very much the model is exactly the same. So we have a cloud-hosted service where people interact with the Funkex system. That's where they register their endpoints. We have the same type of model of a compute endpoint that sits on a cluster or laptop or supercomputer out there on the edge. People speak to this Funkex service in the sky. They register their functions. They can share their functions with other people. They can register their endpoints, and they can also share their endpoints with other people, exactly like the Globus sharing model for data. And via the service, essentially, you can, once you've got a registered function, you can say, I want to run this thing, and you point it at a particular endpoint. You tell us what arguments you want to run, what pieces of data you want to run through that thing, and the Funkex service will essentially go and do all the mediation to make that happen. It'll go and speak to the endpoint. It'll authenticate on your behalf. It'll start sending down tasks. It'll check for errors, etc., and send back asynchronously the results or errors of those individual function runs. Of course, we're working hard to make sure that Funkex is integrated with the Globus ecosystem, because a lot of what we need to do already exists in the Globus platform. So things like authentication, things like management of data, being able to move around and access data in different locations. I have a link here down at the bottom. We have a website. On that website, there is a link to a Binder notebook, where if you're interested in trying this out, you can spin it up on Binder, run through a tutorial, and see all the steps that I'm going to speak about in the following slides, without installing anything on your PC as well, if you're worried about the complexity of setting stuff up. So one of the key points we're trying to focus, as I said, very much on this Globus-like model, where we install endpoints on the edge and we're able to coordinate access through the cloud. An endpoint at the moment is a Python package that essentially could be pip installed. It runs on most systems. I saw a question just before from someone asking, wouldn't it be cool, or can flows speak to different schedulers? And the answer is with Funkex, yes, it can speak to Slurm, it can speak to Grid Engine, it can speak to PBS, it can speak to Amazon Web Services. We have about a dozen different connectors to back-end scheduling systems. And so this Funkex endpoint basically abstracts various types of resources. It's responsible for provisioning resources, for going and grabbing a dozen nodes to run some compute on. It's responsible for managing containers if you want to execute your functions in containers. And of course, that's a nice way of making functions more portable if we can have a common execution environment for our function. And it provides a way for us to share endpoints, so we can say who else can access that endpoint. And importantly, of course, that's sharing endpoints if permitted by the administrators of the system in which you're running. So assuming you have an endpoint registered, the next thing that Funkex allows you to do is to register and share functions. We have a Python SDK here that looks a lot like the Globus SDK. You create a Funkex client, you go through the normal Globus Auth flow to go out there and consent, access, authenticate with one of your research identities or other identities supported. You can then just work exactly like you would in Python. You define a Python function, you can register that with the cloud service, and you get back a UUID for that registered function. Once you have that UUID, the next task is essentially to just invoke that thing. And again, through the CLI, we have this run command where you basically specify the endpoint ID on which you want to run a function. You specify the ID of the function you want to run, and you pass in any arguments that you want to pass to that function. And those arguments are just standard Python arguments. You can pass in pointers to Globus files, et cetera, et cetera. This is inherently an asynchronous model. So what you get back is an ID for that task that you've asked to run. And at some point in the future, you can then go and grab the results. Funkex also has things like batching support, et cetera, so that you can scale the sort of size of tasks that you want to run. So that's a whirlwind tour of Funkex. There's a lot more information on our website. There's also the Binder link there, so you should be able to go and run through the tutorial and get an understanding of how all that works. The endpoint software you can set up in various places. I would encourage people to try it out. Let us know. As I say, it's an active research project. We have a Slack channel, so join us on Slack and let us know features that you'd love to see, or things that aren't quite working the way you would want them to be working. And I should also say thank you again to the NSF for supporting this project. So I think I still have a couple of minutes left. So the other thing I wanted to talk about was how our team is applying the Globus platform to a bunch of problems at Argonne and more generally across the DOE ecosystem. And what we see a lot of, and Ian and Rashna have alluded to this in their slides, we see a pattern that looks a lot like this with instrument science, where we have some sort of operator, researcher, experimentalist who's running an experiment. They're capturing data, they sit there at their PC, and they always come to us and say, wouldn't it be cool if I can see the results of my experiment as it's happening? Can I reconstruct the pictures that are coming out so I can look and see, well, does this look right? Am I getting something interesting? Is something broken? Do I need to go and fiddle with the machine or change the sample? And increasingly, of course, people, the next thing they tell us is, well, wouldn't it be even cooler if I can run some magic ML algorithm that's going to do some processing on that thing and tell me the answer? It's going to tell me how I should be changing my sample. And so this sort of looks like the left part of this diagram here, where essentially the process for doing so is we need to take the data from whatever the instrument is. We need to move it to a system in which we can actually run some compute. Generally, these reconstructions or machine learning models can be relatively computationally expensive. And we need to provide feedback to the operator. So you can see there already, there's an obvious need for, let's transfer some data, let's run some compute, let's provide feedback in a visual way that a person can steer what they're doing. The next thing they say is, well, that's great. Now I've come to the end of my experiment. What I need to do is I need to save everything. I need to catalog it so that I remember exactly what I've done, what the results were, and I need to make that accessible to collaborators or friends and family in different places, potentially publishers. And on the right there, you see a list of examples of use cases where we're deploying this sort of canonical flow at the APS and other research facilities. So one advantage we have at Argonne is that Globus and FunkX increasingly are quite widely deployed. So on the right here, you see a picture of the APS beamline, or the APS at Argonne, and you see a bunch of Globus Connect logos around the beamline. So the good thing there is we have this data fabric that's fairly generally deployed at Argonne, and we have one FunkX endpoint up the top there. You see it at one of the systems. On the left, you see some of the computing facilities we have at Argonne. So the ALCF with Theta and Cooley, the Bebop cluster and the LCRC, and of course some computing at the APS. And these things also have FunkX and Globus deployed. So the great thing is we have this fabric of computing and data management, and that allows us to very easily sort of dynamically or reliably and dynamically submit tasks and transfers to these various places. So what we've been doing is we've been using the Automate platform in as sort of beta testers to try and get to work through all the functionality that we need out of Automate. And we've been developing a bunch of Automate flows that move data around and try and implement that canonical flow that I showed you before. One very quick example, because I know I'm on negative time, is an example from Zhengchun Liu and colleagues at Slack, where they're essentially, you see up the top here, this picture looks very much like the canonical flow I showed you before. The idea here is that they want to be able to deploy deep neural networks at the instrument to do processing of data as it comes off the instrument. In order to apply those deep neural networks at the edge, what they actually need to do is they need to train these things, and they need to train them on a combination of simulated data and also data that's actually being acquired from the instrument. So what we have here is we have an Automate flow that takes data off the instrument as it's acquired, transfers it to a computing facility on the right, runs periodically these machine learning model training steps with the running simulation piece, and then ships the trained models back again to the edge to actually run these neural networks in real time on data that's being acquired. Rashna also highlighted a few examples where we're using APS, but this is just another example where we're doing it in a much more wide area way. We're actually shipping data across the country as part of this flow. So with that, I think I'm out of time. I'll hand it back to Vas to finish off the presentation.
Thank you, Kyle. Thank you, Rachna, and thank you, Ian. So I have just a couple of things that I wanted to touch on. Let me just share my screen here.
While you're doing that, Vas, I just wanted to say one thing. I wanted to give a shout out to Professor Rafael Montoya, who's visiting with his students from Italy.
Nice to see you, Rafael. Okay, so those of you that are repeat offenders at GlobusWorld events will have heard me do some version of this talk, which usually entails me subtly pleading with folks to become paying subscribers, because the vast majority of our users still don't pay anything, but they do get, I think, a lot of benefit from the service. But I thought in light of the fact that we've all lived through various phases of doom and gloom over the past 15 months, rather keep this more upbeat and really focus on the things that are driving our sustainability mission. So this is our stated mission. Some of you have probably seen this many times. We are trying to make data-driven research more efficient at multiple levels, but trying to do that in a sustainable way so that Globus is around for the very long term. So I thought it's worth looking at how we're doing so far. One of the very encouraging signs in terms of adoption is to actually see the sort of global reach that the platform is starting to achieve. And thanks, of course, to all the various, the tens of hundreds of thousands of users that are out there actively using it, promoting it to others, and so on. We're at over 70, I think about 72 or 73 countries now with active endpoints in the past year. So that is, I think, great from our perspective. You can see the heat map obviously skews very heavily towards the US. That's still by far the sort of most dense adoption, but there are substantial, in some cases, many hundreds of endpoints and thousands of users in quite a few countries around the world. Back here at home, one of our primary sort of focus communities is the large research universities, the so-called R1s by the Carnegie classification. There are, I think at last count, 130 of those. And as of last year, or over the last 12 months, all but 4 actually use Globus. And it's encouraging to see that more than half of those are now subscribers. So I do want to shout out to all of those of you that are with institutions that are current subscribers, and thank you for spreading the word and continuing to champion the cause here. So we're seeing great traction there, and this is also filtering down to the R2s, R3s, the smaller schools. And from my perspective, I think all of us here at Globus, it's really an important part of the mission to bring these kind of capabilities not just to the proverbial 1%, which are sort of the large, well-funded schools, but to researchers everywhere. And we are starting to see that taking place to some degree, and we're also working with other groups like NRENs and others that have reach into sort of the diverse range of institutions to try and make the services available through different channels. The other big footprint that we have, and you saw a number of examples from national labs, and so we do have a presence in almost all the labs. I think there's 2 or 3 folks that are not using Globus actively, although they do have, I think, older versions of Globus in some form. But we have about half of them as paying subscribers, and they continue to be a very important part of our sustainability story. I did, as I was going through the numbers, sometime really early this morning, I thought I came across some interesting tidbits that I thought I'd share with you. And the one that really stuck out was this number here. So Greg Naraki, who you'll hear from in a bit here, moderating the questions, he ranks all our users. He's got this very fancy algorithm that analyzes volume of transfers, number of users, number of shared endpoints, and so on. And this is, as of the last run, this is the amount of data that was moved by endpoints at UCAR over the past year. So that's, what's it, about 5.5 petabytes a month. So starting to get up there a little bit. We hopefully will get to a few tens of petabytes every month collectively here. The NIH, again, has been supporting us for many years as subscribers. Quite a few of the institutes there have Globus deployed, and they happen to be by far and away the one institution that uses the Globus sharing capability to make data available to both internal and external collaborators. So that's the number of shared endpoints or guest collections, as they're called now with Globus Connect server version 5, that they've had active over the past year. And then Berkeley Lab, so the folks out at Berkeley and NERSC as well were very early adopters. In fact, I think David Skinner and a couple other folks out there, Eli Dart and so on, were the very first people outside of the Globus team that did a Globus transfer. And so they are now up there moving hundreds of thousands initiating hundreds of thousands of tasks every year. So with that, I would like to thank the funders that make a lot of this development possible. Ian and Kyle mentioned some of the grants that are funding our current and very exciting efforts. We continue to get support from all the agencies listed here, as well as support from other commercial and other institutions. So thank you to all of those. But again, a very big thank you to our subscribers, who are really the sort of the linchpin in our sustainability story. And so with that, I'm going to
another question about flows. Will flows be able to integrate with job schedulers like Slurm?
Yeah, so I think Kyle mentioned that. So from a pure flows service perspective, the interface it has is to any action provider. So anybody could write an action provider and have it potentially interact with a scheduler or submit jobs and things like that. So that's the general interface. But as Kyle said, FunkX, which also is an action provider, so one of the steps in the flow could be call, run this compute for me, already does a lot of that for us and provides that next layer of abstraction to the compute system itself. So we should be able to support what is being asked there across a wide variety of compute systems and schedulers. Kyle, is there anything else to add there?
I think the only thing I'll add is I think I see FunkX as being a really important part of the Automate platform story, because a lot of the flows that we're running do have this compute component, and FunkX registers as an action provider provides a really general way of running things in various locations. So I think that's going to be an important part of our story going forward.
Okay, another good automation question. For transfer automation, does Globus support the concept of a service account? Talking about an entity that's not a real person, but a managed service account with a Globus identity that is able to schedule automated transfers between endpoints.
Yeah,
and I don't know if that's an, yeah.
Sorry. Yeah, the answer is yes. You can certainly set up a service account, and the way you do that is register it as an app in GlobusWorld. So GlobusWorld as an IAM, identity and access management platform, supports not only user authentication and such, but also allows you to register apps and resource servers. So the way you'd solve that is by registering your service account, and that credential is managed in Globus in the Oauth interface that could be shared amongst administrators, and then can be used for interacting with the Globus infrastructure. The data infrastructure also treats that identity of that app or that service account as a first-class identity. So you could give that app permissions to access data on a guest collection. You could give that app permission to submit transfers and check monitor transfers and so on. So it can be treated as a first-class entity within our ecosystem. And that's sort of what I was referring to when I talked about us spending more time thinking about the task throughput for such service accounts, because today, if you're using transfer, there are some limits on how many concurrent transfers that run and how many pending transfers you can have, which are largely resource preservation limits. And when you have a service account like that, that perhaps is proxying for or automating at scale, we might want to rethink how we provision those things. So that's something that we're definitely interested in. And I think Kirsten's talk later today would have some interesting uses of that concept as well.
Okay, great. And the last question that we have here, oh no, another one just came in. Are there other authentication mechanisms to use Globus with Jupyter notebooks? I'm thinking here of the 0 to 1 Jupyter Hub. It appears you will have to authenticate through Globus. The last time I used Globus authentication, I had to go through 2 interfaces, Globus first, and then my institution's login page. Can I just go to my institution's login page? And I know we're going to be covering some of that tomorrow when Vas and I do some of the demos, but Vas, I think you had some input here.
Yeah, so that flow that you see is actually the standard Oauth flow, which is what we use. So you Globus recognizes that you want to log in with a credential from another institution and has to redirect you to that institution's identity provider so that credentials don't flow through the Globus service. There is no sort of automated way for Globus to intuit where you're coming from unless you tell us, and we get that from the identity with that you present, or the identity provider that you select when you decide to log in. So and the Jupyter Hub integration that we have in place, which uses Authenticator plugin, does exactly that. It actually just takes it redirects you, gets back the credentials from your institution, and then puts them in the Jupyter Hub state in memory, so you can read them out in the notebook. So that, yeah, that's just, we're not doing anything different than the standard OAuth flow there.
And I just pasted a link in the chat as well, Lee's excellent blog article on this. Okay, another question: are there any new features on the roadmap for Globus High Assurance?
So definitely adding this new services that I talked about today, Globus Search and Globus automation services, flows and such, making that available under the High Assurance tier, so you can use that with protected or restricted data, is definitely on the cards. So we'll be working on that. On the High Assurance data access itself, a lot of the focus, so we just wrapped up MFA, and some of the permission management aspects where you can set permissions on a guest collection that expired at a particular time, or allow users to only touch it once. Those sorts of things will be coming down the pipeline. So I think those are a couple of dimensions. I don't want to mention other security standards. There are many that are coming out, including things that are still sort of not set in stone or not very clear methods for us to get certified. So we are watching that space and seeing what sort of compliance requirements are coming down on campuses and how we can get our services geared up there. So if you have specific requirements, please do send it our way, and we'll definitely evaluate that.
Okay, great. Well, that was the only question I saw. The last question I saw here.
Okay. So before I turn it over to Vas for the last piece, I just wanted to give a shout out to everyone in the Globus team. It's an incredible team of people we work. I was a spokesperson for a lot of work that's being done by the team back here. So to the Globus product team, support team that I think a lot of you interact with, the business support team and the customers team, everybody has done an incredible job, and yet another year where we have had some solid additions to the product. So thanks everyone, and thank you all for joining us and continuing to support Globus here.